Welcome, this is the AP Physics Kinematics lecture on projectile motion, part 1. These are the objectives for the lesson. We'll start off with looking at what a projectile is. In simple language, it's throwing something. An object can be launched, thrown, or fired under the influence of gravity only. The trajectory of the projectile is parabolic, which is your x squared term. And what is significance about the gravity only? Gravity refers to the acceleration of gravity. Gravity only implies that the acceleration of gravity is the only acceleration that the object experiences. That means mathematically, you will have an AY term equaling to gravity. That means the acceleration of gravity operates in the vertical direction only. That is your up and down, which means projectiles are accelerating only in the Y direction. There is no horizontal acceleration. That means AX is equal to 0. There is never a horizontal velocity. Objects will always move at a constant velocity in the x direction because there is no acceleration. We want to look at a scenario here. You might see in your books, a rock or something is thrown off a table, cliff, or a tower. Figure 1 shows an object that the ball is dropping from rest, and figure 2 has the ball rolling off the table with a horizontal velocity. You would like to analyze the graph and see certain things from it. You should notice that figure 1 and figure 2 have the same vertical velocity. You can look at it by looking at the arrows pointing down. Notice these are the same lengths. Okay, the third time the vertical velocity is equal to this vertical velocity. The fourth time span, this vertical velocity is equal to this vertical velocity. The vertical velocity increases over time due to the gravity accelerating it. So notice here it starts off small, then the velocity gets bigger, okay, bigger, and here it's the largest, because again, what is causing that is the acceleration. So if this is the initial, right, the new one that's making it longer and longer is the acceleration. Both figures experience a constant acceleration during the entire time. The constant acceleration is going to be due to gravity. So constant acceleration is your g, which is 9.8 meters per second squared, which is downwards. Figure 2 is different than figure 1 because it has a horizontal velocity. So this is the horizontal part. And the horizontal velocity is what causes the object to move in this path. Without the horizontal velocity, it would just fall straight down. Figure 2, horizontal velocity is constant during the entire time. You should see the value here of the horizontal. It's the same length. That's what they mean by constant velocity. The reason why it has the same length over the period of time is because there's no horizontal acceleration. Remember, gravity only affects the up and down vectors. So, my question is, given this scenario, which one hits the floor first? For this, we could look at our kinematics equation. You're solving for t. If you look at your formula sheet, you might see this version. Y is equal to y naught minus 1/2 gt squared. Okay, this goes to 0. Okay, or it moves to the right. and you're still going to get delta y equals to negative 1/2 gt squared. Please understand that delta y is referred to the height of the table, cliff, or tower. When you plug it in, it's going to be a positive value, because when you plug it in, the negative here just tells it's a downward direction. So here you would have to look at that time is the same for both of this figure, because time only depends on two variables: the height, delta y, and gravity, nothing else. No mass is involved when it comes to the time. This is the reason why the figure will fall and hit at the same time, because they're falling off at the same height and they experience the same amount of gravity. You might see this in the textbook. This is a photograph showing the different position of two balls at equal time interval. One ball is dropped from rest and the other one is projected horizontally outwards. Which one hits the floor sooner, the faster ball or the slower one? And we should see as a result, Galileo, who predicted this, will say that in the absence of air in a vacuum, objects will fall and hit the floor at the same time because they experience the same amount of gravity. Independence of motion. We could see that this is on your formula sheet on the AP Physics exam. This is on the formula sheet. And to get it into this version, you have to get it to replace this version, you just replace the x with y. Okay? And here you should see that both of these are mathematically independent. That means you can do this problem, the x component problems, and by itself and solve for it, and the y component by itself, and you could ignore each. This is the reason why there was a lesson on kinematics, which was just looking from the horizontal direction, and there was another lesson on free fall, which is just up and down. And we saw we could have done the math independent of each other, and it would be perfectly fine. While x and y motion solves independently, they still take place at the same time. Time is the only variable that is shared between both the x and y direction. Once time is solved in one direction, it can be applied to the other one because they share it. This makes time a critical variable. While these two look exactly the same, you could go in between them by solving for t. What I did here is I showed how to get t from the equations. Please understand that this equation that I'm getting here comes from this part. But you're like, wait, where's the negative coming from? Please understand that ay is equal to negative g, which is equal to negative 9.8, because we are taking the downward direction to be negative. By default, anything up and to the right is positive, so anything going down is negative. This is the reason why it's negative. All right. But again, if you still solve for t, t is equal to the square root of 2 times the height divided by gravity. If you look at the horizontal part and you want to solve for time, you need this is referred to the range, or how far the object goes, and this is the initial velocity in the x direction, So these are the two ways you can find time. To understand, this is more common, is to find time from free fall, and that is t equals to the square root of 2 times the height divided by g. This is a typical projectile question where an object is launched from the ground and it follows this sort of path. You should analyze this graph and see a couple of things. First, you should see that the horizontal velocity is constant during the entire path. This is the horizontal velocity. Look, during the entire path, it is the same length. And the reason for that is because ay equals to 0. Sorry, AX equals to 0. Gravity is constant, pulling the object down towards the entire time, so this is always constant. The fact that it's always pulling the object down, that is why gravity is what is causing the vertical velocity to decrease over time. So this is the initial velocity, right? Then this one is a result of, so this was the initial, right? Then you're going to add the gravity, which is AY, which is down here. So this equals to this. That's the reason how you got here. Okay? And at this point, there is no vertical velocity at the maximum point. This is at the maximum height, right? Then as a result, the velocity vertically becomes negative down the rest of the path. So at the maximum height, there is no vertical velocity because there is horizontal velocity. So some things that you have to look at is that if a object is thrown or launched at a theta, which is an angle measurement, you have to be able to convert it. So the example is this. Some things that you should notice is that if this is the launch at 50 meters and this is theta, which is equal to 37 in this case, the x component part, okay, this is its adjacent side. This is the cosine part. And this is the y part. And that's the opposite side. And that's going to be your sine theta part. Okay? Please understand that this follows the unit circle. Okay? And if this is 0 and this is 90 degrees, right? Here, at 0, your cosine of theta equals to 1. Here, your cosine of theta equals to 0. So as you get above, as you go to 90 degrees, your cosine part, the cosine theta goes towards 0. Okay? Likewise, if we now look at the sine part, okay, the sine here, theta here is 0. Okay, as we go vertically at 90 degrees, sine of theta is equal to 1. So as you increase, sine theta approaches 1. So the more 90 degrees it is, the more vertical velocity that you have, and more towards the 0 side, okay, you're going to have more horizontal velocity. And these are the components. Looking at it, some language terms that you want to take a look at is your delta x refers to the range or how far the object is being launched. Delta y is referred to the altitude or how high the object is. Understand that t is the time of flight, and that is the same in both directions. Sometimes you have to find theta by using the tan inverse, and if you ever want to solve for the velocity, we give in your Vx and Vy, you could just use your Pythagorean theorem to solve for that, because again, it follows a right triangle. If we look at the kinematics equation for constant velocity or constant acceleration, this is the original equation. Then we modify it for the y. Please understand that these are negatives because ay is taken to be negative g. And now we're going to modify it for the x direction. Please understand what I mean by modify is we know that ax is equal to 0. That's why these are going to be canceled out. Once these cancels out, the equation becomes something very elegant. And this is what you should try to use when you do projectiles. All right. So on top here, you see the original equations. And on bottom here, everything is adjusted. So we could see that the Vx becomes this. So the final velocity in the x direction is just the velocity in the x direction starting, because again there's no axt version, so this goes to 0. Okay, this goes to 0. And this now, from the x equals to x naught plus the initial velocity in the x direction times time, again that is because this goes to 0. Okay, that's why there's basically only two equations left in the x direction, assuming that the ax equals to 0. Next, you keep all three parts of the y component, but please understand that the g, it's now minus. And the reason why it's minus is because we adjusted for gravity and the vector of gravity. Because remember, we note anything going down is negative. That is the reason why when you substitute here, it's negative g. All right. What I would like you to do here is to identify the correct variable sign at the key parts of the projectile. There are 4 parts. At point A, how is the object going? Part B, part C, and part D once it lands again. So at part A, the vertical velocity is still increasing. We don't know. We know at point B it becomes 0 because the gravity is pulling it down and it stops here. So Vy equals to 0 at maximum height. And at C, we notice that it is already coming down. And at D, it's still coming down at the moment before it touches and hits 0. If we look at for the velocity in the x direction, we see that it is increasing. It stays the same value. So it stays positive during the entire time. There's no increasing. This is constant during the entire path. Ax, we know that the acceleration in the x direction is 0. There is no horizontal acceleration during the entire path. We know that gravity is what is causing the y direction velocity to decrease. So we know that this it's just all the different ways of just writing it. Okay, this is again constant during the entire path, and time is always going forward, so we take that as to be positive. What I decided to do now is give you some values like theta equals to 37 degrees, and we say that the initial velocity is 20 meters per second, right? We could label this for a certain thing. So at the start, the object is going at 12 meters per second. How do I get that? Again, Vy is equal to V naught times sine theta. So I plug these in, and that's how I got the value of 12. I do not know what's for A, but I know at B, it is going to be 0. Okay, so this during A, it's in between 12 and 0. Okay, it's in between these. So you can just say maybe A is in between, is less than 12 but greater than 0. Okay, that's what we know that. And we don't know C, but we know D is when it comes back down right before it's negative 12. And again, as it's coming down, we know that A has to exist greater than negative 12 but less than 0, because it has to be in between here somewhere. Okay, the negative just means it's pointing in the down direction. And we know that the velocity in the x direction is constant during the entire time. How do I get that? Vx is equal to V naught cosine theta. That's how I got that 16. Ax is 0 because there is no horizontal acceleration. Ay is the same thing of negative 9.8. The negative comes from it being pointing down. Time, we just know it's increasing their entire path. Let's take a look at the equation now. We can analyze the upward launch. Please understand that the range is determined by the horizontal displacement to the velocity in the x direction times time. The altitude, or how high the object goes, depends on vertical displacement due to the y velocity, but that decreases, right? This is going to be decreasing. Please understand where the minus is. It's decreasing over time due to the gravity vector. Okay? We could analyze this by going this graph. Here they found the vectors in its values. Now they're going to graph it. So at the start, it's constant at 20 meters per second going to the right. That's why that length never changes. Then you see that at the start, it starts off with 20 as the Vy. Then it decreases. Again, this is due to the what? This is the gravity part. That's why it's getting smaller. At this part, it becomes 0 at its maximum height. Now gravity is super stronger, so that's the reason why it causes it to go down. Gravity pulls it more down. Gravity pulls it more down. So this is the math example giving that. To recap, x motion is always constant, velocity and always positive. That's how it goes to the right. Any 2 points with the same altitude, the same magnitude, and velocity is the same, the direction is opposite. That means this point and this point is the same in magnitude. They're just pointing in different directions. At the very top, there is no y velocity because that is due to